In this video, we're going to go over the different shapes of a distribution. So the first one we're going to consider is a symmetric distribution. Now, why is this distribution symmetric? If we draw a line right in the middle, notice that the left side is basically identical to the right side. And so that makes this distribution symmetrical. And right in the middle, we're going to have the mean. And this also represents the median, which is in capital M. Now on the x-axis, we basically have the values. On the y-axis of this graph represents the frequency of those values. So where do you think the mode is? The mode is basically located at the point with the highest frequency. It's basically the value that appears most often. So the value at the highest frequency is here. So for a symmetric distribution that is unimodal, where you have one mode, the mean is the same as the median, which is also the same as the mode. So remember, the mode occurs when the frequency is at its highest. It's the number that appears most often in a list. Now let me give you an example of a unimodal graph. This here is a bimodal graph. And what we have here is a trimodal distribution. So this is unimodal because there's only one mode. This is bimodal because, as you can see, there's two modes. And this is trimodal because there's three peaks, there's three modes. You can also say that it's multimodal because it has many modes. Now let's go back to a symmetric distribution, but for a box plot. So this is Q1, the first quartile, this is Q2, and this is Q3, the third quartile. So this box plot, or this box and whisker plot, represents a symmetric distribution. Notice that the length of the first box on the left is the same as the length of the box on the right. So what this means is that Q3 minus Q2 is the same as Q2 minus Q1. So that represents a symmetric distribution. The second thing is the length of the whiskers. The whisker on the left is equal in length to the whisker on the right. So everything about this box plot is symmetrical. Now here's another distribution for you to consider. Would you say it's symmetrical, or would you say it's skewed to the right or skewed to the left? So notice that we have this tail of data on the right side. So therefore, the distribution is said to be skewed to the right. Some textbooks will refer to this as a positive skew. Now, where is the mean, the median, and the mode in this case? The mode is going to be somewhere over here. I mean, not the mode, the median. This is the median represented by capital M. Now, where is the mean relative to the median? So because the data is skewed to the right, the mean is going to be to the right of the median. So we can say that the mean is greater than the median. Now what about the mode? The mode occurs at the highest frequency. So basically at the top of this graph. So the mode would be right here. So notice that the mode is less than the median, or we can say that the median is greater than the mode. So in a unimodal distribution, the mean is going to be greater than the median, and the median will be greater than the mode. Now let's talk about the shapes of the box plots for a distribution that is skewed to the right. So here's one possibility. Notice that the length of the whiskers are the same, but the box on the right is longer than the box on the left. So, as we said before, this is Q1, Q2, and Q3. So Q3 minus Q2 is greater than Q2 minus Q1. In this case, the data is still skewed to the right. As you can see, the right box is longer than the box on the left. Now, let's say if the boxes in the box plot are equal in length, but the whiskers are not. The data will still be skewed to the right in this case. So for this example, Q3 minus Q2 is equal to Q2 minus Q1. However, the whisker on the right is longer, and so the data will still be skewed to the right. Now sometimes you can have a combination of the two. So the box on the right will be longer than the box on the left, and at the same time, the whisker on the right could be longer than the whisker on the left. So this is another example in which the data is skewed to the right. Now let's talk about the third distribution that you need to be familiar with. So in this case, notice that the tail of data is on the left side. So therefore, we could say that this particular distribution is skewed to the left. Some textbooks will refer to this as a negative skew. Now the median will be somewhere in this region. So where is the mean with respect to the median? Will the mean be to the left of the median or to the right of the median? So because the data is skewed to the left, the mean is going to be to the left of the median. And that's one way in which you can remember that. So therefore, the mean is less than the median. And as we know, the mode is going to be basically where the data is at its highest point. So the mode is the value with the highest frequency. So notice that the mode is to the right of the median this time. So the mode is greater than the median. So in summary, remember this. For a distribution that is skewed to the left, the mean is less than the median, which is less than the mode. Assuming, of course, it's unimodal. Now let's talk about the box plots for this type of distribution. So let's say that the length of the whiskers are the same. The box on the left is going to be longer than the box on the right. So in this particular instance, Q1, or rather, let's say Q2 minus Q1 will be greater than Q3 minus Q2. Now the second type of box plot with a negative skew will look like this. Let's say if the two boxes are equal in length. That is, Q3 minus Q2 is equal to Q2 minus Q1. If the whisker on the left is longer than the whisker on the right, then it also will be a distribution that is skewed to the left. And finally, we can have a combination of the two. The box on the left can be longer, as well as the whisker on the left. So that's another box plot that has a negative skew or is skewed to the left. So that's basically it for this video. Hopefully you have a better understanding of skewness and the different types of distributions that you need to be familiar with. Thanks for watching.